Oh, I really hate that I'm going to have to be here for this, but that's okay. Could you imagine 75 whole minutes, one seat, just stuck in spot, torture? And you know what? Next period, I'm just going to have to do it again. Oh, anyway, can you imagine? Anyway, at least I'm being paid many thousands of dollars. Yeah, sure. Oh, please. They're lovely. They're actually a delight. I really like them. I'm just always so tired by third period now. I'm turning into an old man, and I just need a nap. You know what I need third period? A nap. Let them have nap time. Could you imagine? All right, guys, today's lesson is... We're doing a sleep lab. I did a sleep lab once, and then I also just had to get like a sleep test done once. And let me tell you something. There's something really funny about you go to these things. They're like, all right, so we're just going to have you sleep naturally now. And then they like shove prongs up your nose, like a mask over your mouth, and like ECGs on, and like a heart rate monitor here. And it's like, all right, now just sleep like you normally would. And you're like, how do you normally sleep? This is not how I normally sleep. So I was up all night, and they're like, yeah, you had a really bad sleep. I'm like, I don't know that this is representative. Do you know what I'm saying? Like, I don't know that this is really capturing what a regular rest period for me looks like. Anyway, that's the end of my story. It's a very good story. You're welcome.
What you're saying is I'll find a way to monitor sleep without all the prompts and stuff.
Yeah, I don't know. You felt sort of like a science experiment. Anyway, so you're saying I should do a sleep lab with my third period class?
Yeah.
I like it. I like that.
Yeah.
You know, I don't like them. Yeah, pack of mutants. Not a fan. But my third period class, they're cool. Anyway, let's get to it. So today we're going to talk about the mole as a practical measure. Why in the world did we settle on this number, and that's a terrible writing of that, of 6.02 times 10 to the 23rd for how many atoms we're going to put in a pack of atoms, right? Why not? Even if this is the right scale, why not 1 times 10 to the 23rd? Wouldn't that be easier? Wouldn't that make for less messy math? And it would, right? A lot easier to multiply by 1 than to multiply by 6.02, right? Our whole decimal system is based on multiplying by 10 because that's easy, right? In decimal math, we always multiply by tens, and all you have to do is tack on a 0. So why this number? And the answer is that it's a bit of a trick. What is the lightest element? What's the lightest element? Come on now, this is... No. Hydrogen is correct. Good. Okay, how much does it weigh, basically? 1.00794 atomic mass units. Okay, the reason we use this number is this. If you take 6.02 times 10 to the 23rd hydrogen atoms, it turns out that weighs exactly 1.0794 grams. And that is actually really convenient because, listen, what that then does is it takes counting atoms, which is something we can't do practically back in the lab, and turns it into something we can do, which is weighing things, right? We can get a scale out and weigh things, right? Does that make sense? So the reason we pick 6.02 times 10 to the 23rd, the reason we pick Avogadro's number, is because it just so happens that's the conversion factor between atomic mass units and grams. 1 gram is 6.02 times 10 to the 23rd atomic mass units, which means that if you have 6.02 times 10 to the 23rd hydrogen atoms, that will weigh 1.01 grams. If you have 6.02 times 10 to the 23rd carbon atoms, that will weigh 12.011 grams. If you have 6.02 times 10 to the 23rd calcium atoms, that will weigh 40.078 grams. Does that make sense? We pick this number because if you have a mole of atoms, its mass in grams, which is very easy to measure. You go get a scale. We have fairly expensive scales here, but you could buy a cheap scale on Amazon for like $12 and do this. If you get a cheap scale and weigh out 12.01 grams of carbon, shave 12.01 grams of, graphite off a pencil, you now know that you have 6.02 times 10 to the 23rd atoms, because that's the conversion factor. It's the conversion factor between one atom, which has a mass in atomic mass units, and how that many atoms you need to have that same number of grams of that atom. It's a conversion factor to grams, and we can work with grams readily. Does that sort of make sense? Maybe, kind of. No. What I'm seeing is a sea of faces going, not so much, but it's going to have to. So we're going to have to work with it. So let's work with it. Let's try and make sense of it. So need my glasses to see where my glasses are. Anyway, there we are. So the basic idea of this: 1 mole of carbon, which has an atomic mass of 12.001011 atomic mass units, weighs exactly 12.011 grams. Okay, so that would mean iron, on the periodic table, we see iron, it has what symbol? Fe. It has what atomic number?
26.
And is it 55.45? What's its mass?
55.
With 845. That's right. Okay. So that means that a single iron atom weighs 55.845 atomic mass units. But now what we're saying is it also means that therefore 6.02 times 10 to the 23rd iron atoms, which is what we call 1 mole of iron, weighs 55.845 grams. Does that make sense? So if I said go get a mole of iron, you'd go back in the back, take the iron filings, and you'd keep weighing them out until it weighed 55.845. I just gave you a count, right? I gave you a count. Go get 1 mole. That is a counted value, 6.02 times 10 to the 23rd atoms. And you can go do it instantly. You can count those atoms out by weighing out 55.845 grams. So the mole lets us move from counting atoms, which is how we do chemistry on paper, to weighing out materials, which is what we do in the lab. It is the thing that lets you work between the two. Yeah. 1.00 moles of iron. Let me try that again. Because again, the definition of 6.02 times 10 to the 23rd, that is a mole. That's what we call this unit. And so now, this number on the periodic table, we've always called it the atomic mass, but no chemist who actually does chemistry calls that the atomic mass, even though that's what it is. We all call it the molar mass because it's the mass in grams of 1 mole. So what we can take from this is we would say that the molar mass of iron is 55.845, and this is the unit we're going to use all the time now, grams in every mole. So that M stands for molar mass. And it's always funny because when I teach grade 9 and 10 science, I'm constantly accidentally saying molar mass, and I'll be like, oh, right, you don't know what that is. Atomic weight. And it is the atomic weight. But again, for a working chemist, I am never going to work with an individual iron atom. So it means nothing to me that it weighs 55.845 atomic mass units. An atomic mass unit is a uselessly small unit of mass, right? As a working chemist, what you're going to work with is the fact that you're going to, every time you need a mole of iron, you're going to go weigh out 55.845 grams. Which, by the way, means that if you needed 10 moles, you would weigh out 558.45 grams. And if you needed 0.1 moles, you'd weigh out, which is the thing we do most often. When I make a solution back there, 9 times out of 10, I'm getting 0.1 moles. and putting it in 100 mils. That's my life. My life consists of looking up the formula weight of something, dividing it by 10, weighing that out, adding it to 100 mils of water. That's my life when I'm getting labs ready. But it lets us work in grams. Well, what we're actually doing is counting. That's a number of atoms, because 1 mole is a number. It's a counted number, which means we're going to be able to do our recipe with it. One of these atoms plus 2 of those atoms gives us this thing, but it's at a scale we can work with, which is weighing things out. So now, the problem is we don't always want 1 mole. And again, to make my life easy in the back, I tend to take a mole or 0.1 moles or 10 moles. But in practice, sometimes you don't need 1 mole or 2 moles. Sometimes you need 3.46 moles. I don't know why, but sometimes you do. In this case, we need it because the question says we do. So, what would the mass be if I told you to go weigh 3.46 moles out? We'll do this one together. Bless you. And we'll say, okay, we have 3.46 moles of iron. And what do we always do with dimensional analysis? We take our given number and units and we multiply it by a fraction line. All right? Again, we're going to do that in chemistry every time, just by default. We're going to do it just by default. No thinking about it. Could I give you a miserable job? Would you mind unboxing all of those calculators? And then we're going to need to make labels for them. But first, just unbox them and counting them. I don't even know how many Calford ordered. And then we'll get the label printer going. That box right there. Yeah. You can work in the back if Kira's not. There's a big stupid piece of plywood on the table back there. If not, you can work in the back there. You can work here too if you want. And as soon as we do that, we're going to work not with numbers first. We're going to work with units. We're going to say, okay, the question asks me about moles, but I want to find mass, which we measure in grams. So where do I want to put grams? Where do I want to put moles in this fraction? Moles on the bottom, because the trick there, again, it's just a math trick. If you divide anything by itself, it goes away, right? And I'm going to replace it by multiplying with grams. And that math trick means that this is going to work, but I've got to put numbers in here that are true. Luckily, the periodic table always tells you how many grams there are in a mole of anything. And the periodic table for iron, I mean, we have it right here. But if you go look, it tells me that a mole of iron weighs how many grams? So where do the numbers go? Do they go like this? Like that? No, what does this say? This says that 1 gram of iron would be 55.845 moles. Is that what the periodic table tells us? No. So again, if you say it out loud, you'll notice if you screw it up. And so we say 55.845 grams of iron is the same as 1 mole. By the way, the periodic table is always dealing with exactly 1 mole. So that's an infinite number of sig figs. How many sig figs is this number? The periodic table gives us usually a pretty good number. How many sig figs here? Yep, we have 5 digits. How many digits do we have in our given? 3 sig figs. So how many sig figs will our answer have? 3. Is that starting to feel a bit more confident, that piece? Yeah.
Does that start before or after the decimal? So like would I put 3, like if I have a 3 number, like 3 number.
Yeah, like 186, like that?
Yeah, would it just end there? Or would I add the decimal because there's only 3?
If you wanted to put a decimal there, if that's where it belongs, you could. That's fine. You could also not. Usually we don't. You'd probably think it's a little weird if you saw the number 186 written with a decimal there, but it's actually not wrong, as long as that's where it actually belongs. Was that the question you're asking?
Yeah.
Yeah, it's not right or wrong. Like, you can put it or not. So just, in that case, whatever looks more reasonable. And then we can do this actual math. And we'd say 3.46 times 55.845. And, I mean, that's going to be 3 times 50 is 150. 3 times 5 is 16. Is 15. So that's going to be 165 plus 3 times 1. So like 168-ish. And then another half of 55 on top of that, which is like 27. So like we should be like in the 192 range-ish. What do we get? 193. All right.
There's 35 calculators.
Beautiful. All right. Do you know how the label maker works? That's it. Great. Give me 2 minutes because they're going to do the next question. Actually, they're not going to do the next one yet, so I'll get you going in 3 minutes. So when I go to put this answer in, how many sig figs do I need? 1, 2, 3, and all of that gets X'd. And this is either 193 or 194. It either stays or rounds up. What's it closer to? 193. So the answer would be 193. And 193 what? Grams of iron. Great. Now again, keep in mind, this is a counted value. Mole is a counting number. It's a big counting number, but it's still this number. But now we've just learned that if I said, hey, for this reaction, we need 3.46 moles of iron, you could very trivially do a bit of math and say, okay, I got to go weigh out 193 grams of iron. Does that make sense? This is the kind of number you'd find in a chemical reaction. It's counting. And this is what you would actually do in the lab to make that reaction happen. All right. Now, it's not always just going to be an atom. In fact, we've sometimes worked with atoms, right? We worked with like elements. We worked with pure iron and pure copper and pure magnesium, right, in our double displacement lab. But most of what we've worked with so far have been compounds of some sort, right? Magnesium sulfate, sodium chloride, aluminum chlorate, iron 2 oxide, right? Compounds. So let's do that here. What is the mass of, this one's just another, these are both just atom ones. Never mind. I was getting ahead of myself. I thought that said hydrogen gas, but it doesn't. It says helium. I want you guys to try the next two. Work together. Work together. This one here is almost identical to the previous one. Try it out. I'm going to give you guys 10 minutes to solve example 2 and example 3. You can do it. I have faith in you. And by the way, doesn't necessarily mean you can do it alone, but no man is an island. Therefore, do not send to ask for whom the bell tolls, for it tolls for thee, Kartik. That's for whom it tolls. John Doan? Anyone? No? What do they teach you in school? All right, get to work.
The proper formulation of an essay.
Well, it's important too, I guess.
It says 4.0026.
So then for that equation, we should make multiple 4, 6 for multiple 4, 6 Where's that next two?
I don't know.
It's like dividing 10 by 2, so like well, yes, I know that. That would mean like 0.1 times 0.1.
Hold on. Stop. Let's see. 40.278. Oh, 40.078.
Why are you asking? Hydrogen 1.00794.
What? Dude, you have no idea what I'm seeing right now.
Oh, I can see a beast number.
I wish I could like put you in my perspective. It was so hard to see. Okay, well like yours is a lot worse. Oh, okay. Yeah. You lost your focus. You just say I look stupid.
Oh, thank you. Thank you.
I can see like you can see the atomic number.
Yes, where is it? Thank you. Yeah, how do I change it? How do I? Please stop laughing at me, help me.
What do you need to do?
How do negative? How do I do 10 to the power?
I cannot see.
Don't doubt.
How we doing, team? Yeah.
I understand this.
Right? Syntax. Okay, let me see. That's okay. Can we take one? Yeah.
Watch this view, lights.
It is an exponent. Yeah, don't worry about it. E means times 10 to the exponent of, so it reads that as. And that number reads. Yeah. Yeah, so that was good. Yeah, so great.
It's class start. 8, 10.
All right, can we take a look at this? So if we, and I'm not going to draw a little periodic table entry every time, but I will for the first couple, just to help us sort of get in the groove, I guess. Helium gas, if we look at it on the periodic table, helium, and it has an atomic number of 2, and its mass is 4 point what? 4.00260? Ironically, a compound that, like something we just never really work with in chemistry because it doesn't react with anything, right? So not one I work with very often. But this means that the molar mass of helium is equal to 4.00260. And that, did I write that right with the 2 zeros? Yeah, okay. And that's how many grams are in a single mole is correct. Good. So that unit, grams per moles. Boy, you're going to say that a lot this year, right? How many grams are in a mole? All right, and where did we get that number? We got it directly from the periodic table. All right? And keep in mind, listen, the periodic table doesn't know the question you're doing. So it's not telling you how many grams are in 4.86 times 10 to the negative 2 moles. The periodic table did not get written with this question in mind. It always tells you how many grams are in 1 mole, right? Everything on the periodic table is the mass of 1 mole of that thing. So now if we want to do the actual math we have to start with 4.86 times 10 to the negative 2 moles of helium. Now, if you want to convert that to a decimal a simple decimal, it'd be trivial, right? Just move the decimal twice. I like scientific notation. Point being, that's moles. That's a counting unit. We want to get that in mass. What units do I put in my fraction here? What unit do I want to get rid of? Where do I put it? I'm going to put moles of helium on the bottom because, again, that little mathematical trick, you divide anything by itself, it will go away. Then I'm going to put the unit I want on top, which in this case is grams of helium. And God bless you for saying of helium. I really do recommend that you get in the habit of don't just write grams of helium. And certainly don't skip the units. All right? A, I won't give you any marks, but B, more importantly, later on when we get to tricky stuff, if you don't have the units down, you're going to be done for. You won't have a chance. The whole point of this is we work with units. Okay. How many grams are in a mole of helium? So does the 4.0 go on the top or the bottom in this case? The top, because we're saying that there's 4.00260 grams of helium in every 1 mole. That is actually just this written a different way, right? Do we see that? And when we do that math, 4 times 4 is 16. So this should be on the order of 1.6 times 10 to the negative 1. Right? So 0.1, but that's almost close to 5. So like 0.19, is that what we're talking about here? 0.19, what's the third number? 194. And I'm going to stop at 3 because how many sig figs do we have here? 3 sig figs. How many sig figs do I have here? 1, 2, 3, 4, 5, 6 sig figs, right? Uh-oh, is this just 1 sig fig? It's infinite. That's definitional. And so our least significant number is 3. So that's how we report it. What is our unit? Grams of helium, because moles canceled. That's our math trick that we did, right? We made sure that the answer gave us there. And we'd say, therefore, it would be 0.194 grams of helium. How's that feel? Not too bad? Just bad enough? Good. With a bit, I promise, this is not the things people do poorly with. There's lots of things people tend to do poorly with this. With a bit of practice, this is going to feel like breathing. And you're going to get so much practice. Oh my God, are you going to get practice? So now, what about going the other way? This is, after all, a chemist's journey. It's a reference to The Hobbit, which The Hobbit is the first book that J.R.R. Tolkien wrote, sort of set in his Middle-earth. But in the follow-up book, The Lord of the Rings, we learned that The Hobbit was actually written by a character in Lord of the Rings, and it's called, in that universe, There and Back Again, A Hobbit's Journey. Anyway, enough of that. How many moles are in 17 grams of calcium? So in this case, we know that we have 17 grams of calcium, and what we want to know instead is how many moles that represents. What units should I put here? Grams of calcium on the bottom. Why did I put it on the bottom? I should have asked you where to put it. To get rid of it. Math trick, right? You divide anything by itself, it goes away. What am I going to put on the top? Moles of calcium. And I really want you to see my model here too, which is that I never put numbers first. I never put numbers first, and you shouldn't either. Because again, it may not make a difference with a simple question like this where there's only 3 numbers to work with. When you get to more complicated stuff, the whole beauty of this system is work with units. Work with units and then put the numbers in. What are the numbers? What is the molar mass of calcium? Yeah, that'd be great. How much? 40.076. And of course, that's how many grams are in. Sorry? 7 what? 8. Okay. And that's how many grams are in? That's how many grams are in? A mole. You're basically never going to write atomic mass units again. Because we don't care. Because as a working chemist, what we care is that's how many grams are in a mole. It's true that's 40.078 atomic mass units for 1 atom. But now, we're never going to deal with 1 atom again. Because that's not what we actually do in chemistry. Now, with that in mind, where does that number go? Okay, so we put it 40.078, and that's, of course, how many in 1? Why do I put it at the bottom? Why is this wrong? Exactly. Yep, exactly right. It's not true that 40 whole moles is only 1 gram. It's true that 40.078 grams is the mass of 1 mole. What units cancel here? Grams of calcium. What unit remains? This is going to be less than 0.5. I'm going to bet it's 0.4 something. What do we get? 0.43. And it keeps going, right? What's the digit after that? Like this would have been 0.43. Anyone? Anybody? I just want to make sure we rounded right.
I got 0.424.
Oh, 424, blah, 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 blah.
Yeah.
Okay, so if it's 424, blah, 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 and again, depending on which periodic table you use, you may get different roundings, so don't stress about that. Regardless, if this is what we got with these particular numbers, is that closer to 42 or 43? So that particular one is closer to 0.42. Again, because we will from time to time be using different periodic tables, we will probably from time to time have different last digits. That's okay. This guy's not gonna fall. And what would the unit be on that? Moles of calcium. Why did I round at that digit? How many sig figs do we have here? 2 sig figs. How many sig figs do I have here? That one is infinitely significant. Very good. And what about here? 5 significant digits. Good. Which means that the answer has to be 2 sig figs. All right. I'm excited. It's the time of year again when I get to mark 1 million assignment papers where I go. Like that. So I'm looking forward to that. That's always a highlight of my semester. Okay. Questions about that? Because we're about to get a little more complicated, though really a little bit. This is, if you can do this, you got it. Yeah. Was that a hand? It was not a hand. Okay, cool. So now, the only thing that can make it a little bit more complicated is that sometimes we're not working with just, in fact, most times we're not working with just an element, we're working with a compound, right? So in this case, we want to know how many moles are in 3.42 times 10 to the negative 11. Did I mean to make 11 there? That is a really small number, but that's okay. Hey, whatever. Still do it. Grams. And then what's carbon dioxide? What's that formula? CO2. What kind of compound is that? Good. And we don't want to know how many grams of CO2. What does the question want us to ask?
Moles.
How many moles? So we want to get rid of grams and we want to know moles instead. What do I put where? Yeah. And what am I going to put on the top? Moles of CO2. Okay, and then I'm just going to look at the periodic table for CO2. Not finding it. I find CO, cobalt. Is that what I use? No. How do I figure out the molar mass of CO2? Well, the molar mass of CO2 is just going to be the molar mass of carbon, right? Because it's a carbon, and then stuck to the molar mass of oxygen, and then molar mass of oxygen again, so we can say stuck to 2 oxygens. Does that make sense? We did that the other day. How much does a carbon weigh? Oh God, what's that? That's 32 even, so that should be 44.01 grams per mole. Do you get 44.01?
Yes.
Is that what we get? Yeah. Where did I get these numbers? Where do we get these numbers? from the periodic table. Good. Right? And hopefully you've done a bit of practice with that. A lot of people have sent me their practice for that, which is great. So now we know how much a mole of carbon dioxide weighs. Even though carbon dioxide isn't on the periodic table, it basically is. Carbon is on the periodic table. Oxygen is on the periodic table. So carbon dioxide's molar mass can be derived from the periodic table with just some simple addition. Is that logical? Okay. Now again, if you feel totally lost by all this, we're going to get lots of practice. We've kind of been barreling ahead to this lesson. And then after this lesson, we're going to kind of pause and make sure that we're all caught up and we have some time to make sure we're good at it. I pushed through the last unit especially with a bit of pace so that when we get to this stuff that really does feel new, right? This is brand new. This is nothing like what you've done before. We'll have some time to step back and breathe, get a little bit of practice in, make sure we're getting a feel for what we're doing. But now, how can I use that information to answer my question? Where does that information go? Well, it goes in both, right? Because the moles bit goes on the top, but you're right, the number definitely goes on the bottom. 44.01 grams of CO2. And what number goes up here? 1. Yeah, there isn't a number on the bottom of the fraction here. There's just the word mole, but we know that that means 1 mole. And, by the way, why did I stop this at 2 decimal places? Because we're adding, and when we add, we look at the number of decimal places, right? And this is to the nearest second decimal place. This one's to the nearest third decimal place, so we can only go in our answer to the second decimal place. Okay, so then we do this multiplication. Oh gosh, I don't know. 3 divided by 4, this is going to be on the order of like 0.70. This is going to be like 7 or 8 times 10 to the negative 12. What do we get? 3.42 times 10 to the negative 11 times 1 divided by 44.01. Oh, my calculator doesn't like working with numbers that small, so you're going to have to help me out, team. Sorry.
7.770.
Oh, I wonder if one of those should say Mr. Orlando on it. All right, so just make sure you don't label that one. How much? 7.770 9 times 10 to the exponent negative 13. Okay. There we go. So we're going to multiply that to 7.77 because we have how many sig figs? How many sig figs here? Yeah. 3 sig figs. How many sig figs here? Infinitely significant. How many sig figs here? 4 sig figs. So our answer will have to be 3 sig figs. What's the unit? What units cancel? Grams of CO2 cancel, leaving us with moles of CO2. So if I told you to go, oh boy, but I lost some key information there, didn't I? 7.77 times 10 to the exponent negative 13 moles of CO2.
Sucrose, and I got really excited.
Sorry?
I thought glucose said sucrose, and I was like, oh my goodness, I like that element.
Right?
It's a cool element.
Right?
Or compounding.
Yeah. Okay, so the next couple are very similar. So I want you to work through them. Note what we had to do in this previous one. What did we have to figure out before we could really do anything? We had to figure out how much it weighed, right? So in this case, we're going to need to know how much this thing weighs. What is trinitrogen pentahydride? Yeah. And if we wanted to calculate the molar mass of that, what would we have to do? We'd have to take the molar mass of, and how many of those do we have? 3. And then what do we need the molar mass of hydrogen, and how many of those do we have? 5. All right, so you're going to want to do that before you do the rest of the question. That's my little hint for you, and I will then commend that to your doing. Take a few minutes, get these done. And where will you find this information? Sur le tableau. C'est bon.
When are you going to get us on periodic tables?
Oh, yeah, I don't know. Someday. I should do that. I should get on that.
You said you were into
I say a lot of things. I want to laminate them. I was going to laminate them for you. That's a job I could give Ruby. Ruby ever used a laminator? I don't even know where the laminator is now.
I didn't even know we had a.
Oh, we have a laminator. There's not science department. The school has one. Oy. Excuse me.